So generally version control systems fall under two categories. We've got centralized version control systems, CVCSs, and distributed version control systems, DVCS. Now an example of CVCs are CVS, which is an open source product, Perforce, which is a paid product, and Subversion, which is another open source product. Now an example of a distributed version control system is Git, and that's open source, and Mercurial is a paid version of a distributed version control system. So a centralized version control system comprises a single central server that hosts all the version files and directories. Client software is used to check out files from that central server. Now this has been the standard for version control for a long time. It is worthwhile at this point to mention that the biggest disadvantage of a centralized version control system is that the central server that it needs represents a single point of failure. So if that server goes down, then literally no user will be able to perform checkouts or other version control system activities. And in a worst case scenario, in the absence of a backup system, the entire commit history would be lost. Now contrast that to a distributed version control system, the situation is quite different. In this scenario, the client that checks out a repository from a server fully mirrors that repository. And just for some definitions here, server means the version control software running on a server-grade machine, usually remotely or on a remote site that hosts, controls and manages the repository in some way. Client here means software used to communicate with the server. And communication means accessing the repository, reading and writing files, collaborating as team members, etc. So the client software is usually, but not always, desktop software installed on the local machine and can either be command line based or have some sort of graphical user interface. Now the repository, or to be precise, source code repository, is usually a file archive or large collection of source code hosted on the remote server that can be accessed either publicly or privately. Now when I talk about public access, I mean that a repository is accessible to all, and contrasting that to private access, that means that the repository is only accessible to a select group of individuals with some who need some sort of access control, like a username or a password, or be part of some group to be able to access that particular repository. So a distributed version control system client doesn't just check out the latest version of all the files. In essence, the local repository ends up being an exact clone or copy of that remote repository. Right, so let's talk a little bit about Git. And if you haven't guessed it by now, Git is a distributed version control system and of course is the subject of this course. So when you use a Git client, such as the Bash terminal, which you'll be using through this course, or a program like Eclipse, IntelliJ or Android Studio, that again we'll go through in this course, that sort of software that's got a graphical user interface to check out a project or check out a repository from a remote server, then that checked out project is a full version of the remote repository. So even in the event that the server crashes, you can still use your checked out repository to fully restore the repository on the server once it's fixed. And that isn't possible using a centralized version control system. So another big difference between Git and a centralized version control system like, for example, Subversion, is the manner that each manage their own data. So in Subversion, for example, the versions of artifacts, and remember that artifacts is just another fancy term for files and directories. So in Subversion's case, these are managed by storing the files and their change sets or the differences. So in this scenario here on screen, you can see that X1, X2 and X3 are file diffs, or known as differences, and they also can be called deltas. So they're basically a different version of file X for 3 commits. And the same there for file Y and file Z. So the point is that it's stored in that particular fashion on a centralized version control system. So version X here points to a repository or to the repository for a particular version number. Now, Git, on the other hand, stores snapshots instead of file differences. So a snapshot here means the state of an artifact at any point of time. So when you commit, which is a fancy word for saving the state, your file changes, then Git takes a snap or snapshot or picture, if you will, of what all your files of your project looked at or looked like at the moment of that commit and stores a pointer or a reference to them. So if the file hasn't changed, then Git doesn't actually store that file again. All it does is it saves a reference to that file, and hence you can easily revert your entire project to a different commit ID or different version number, if you will, if that need arises. And here X1, X2 and X3 are snapshots corresponding to file X, and you can see the same is there for file Y and file Z. Now the version here X represents a snapshot of the entire repository at a particular instance of time or saved state, which again is that commit word that is used to indicate saving information in version control system. So in Git, everything is local. Now in a centralized version control system like Perforce, for example, you can really hardly do anything if you're not connected to the server. So a centralized version control system like Subversion or CVS is fairly useless if network connectivity is absent. You can edit files, but you can't save changes to them, or in other words, you can't commit anything. But in Git, the situation is completely different. So since the local Git repository is a complete clone of the remote server repository with a complete commit history, you can potentially do every version control system operation except pushing your changes back to that remote server in the absence of network connectivity. So as an example, whether you're in an airplane or your basement without internet, or whether you're just using a computer normally, you can still carry out all your version control system tasks and then subsequently push your changes back to the remote server whenever that network is available. Pretty powerful. All right, so let's move on to the next video.